Humanity thinks it lives in an era where the most important things could already have been discovered. The maps have been drawn, the formulas derived, and space and the universe are just a distant backdrop for imagination and beautiful pictures. But in reality, we live in a moment when humanity is just beginning to truly realize where it is. While some spacecraft are landing on the far side of the moon, others are silently completing their years-long journey in the sands of Mars. And at the same time, many scientists are asking questions that make you feel uneasy. What if the universe is much, much smaller or much stranger than we are used to thinking? What if the boundary between the micro world and the cosmos is an illusion? And what if our place in the universe is much more modest or, on the contrary, much more amazing? We live in an interesting and dynamic time. This fact was once again proven by the Chinese, who launched the robotic spacecraft Chang'e 4 to study the far side of the moon. Our satellite has always interested people on Earth more than any other celestial body. And now the moment of truth has come. Now humanity will finally find out what is on the so-called dark side of the moon, which, by the way, is illuminated by the sun just as much as the near side. The Chang'e 4 lander, named after the lunar goddess of the Chinese pantheon, successfully launched from the Xichang Cosmodrome on December 7th, 2018, aboard a Long March 3B launch vehicle. On the morning of January 3rd, 2019, after a 26-day journey, Chang'e 4 made a soft landing on the lunar surface. It was a sensation. Soon after, Chang'e 4 sent a series of excellent panoramic images of the moon in its natural state back to Earth. Here is the lunar gallery and that very historic photo taken by the lander. Now take a closer look. This is the rover's wheel before it rolled off the platform. And here are the shots showing how the U-22 rover carefully rolls down into the lunar dust. Take a look at this photo. You can clearly see the rover starting to move. A historic video was also recorded capturing the moment of landing. Right now, you are watching a fragment of video from the onboard camera that recorded the moment of the lander's lunar landing. The first images shocked the world. It turned out that the color of the dust on Earth's satellite was completely different from what was expected. According to the photos, the lunar landscapes look more like a reddish Martian landscape. Later, the incident was clarified. The first image was taken with uncalibrated cameras, which is why there was such an unusual effect. This is explained quite simply. If you set different color temperature parameters on the camera equipment, the photos can have either a warm or a cool tint. Here's an example. Right now, the camera is set to a temperature of 2,500 Kelvin. Let's see what we got as a result. Now let's try to take the same photo, but this time with the settings at 10,000 Kelvin. The effect is obvious. It's the same object, identical lighting, but there's a dramatic difference in the color of the images. In the same way, you can change the temperature. For example, in Lightroom, it looks like this. How can you tell if your camera is calibrated correctly? For example, in a photo from the Apollo 17 mission, you can see a special multicolored marker in the frame, which can be used as a reference. On the right, you can see an orange patch of ground, even though the rest of the landscape is in gray tones. Next to it, we see an image with natural calibration. This is a photo of the lunar rover taken by the Tycam camera. It's clear that there is no redness, and now in front of you is the view from the rover to the stationary module. You can notice that the shades are a bit different because the rover has a camera with different calibration settings. But most importantly, we have the first complete 360-degree panorama of the landing site. The landing site of the interplanetary station was the ancient von Karman impact crater. It is part of a global formation called the South Pole Aitken Basin. Aitken is the largest crater on the moon and in the solar system. Its dimensions are 2,400 by 2,050 kilometers, and its depth ranges from 8 to 16 kilometers. Before landing, Chang'e 4 used terrain pre-scanning technology for the first time to determine the most suitable landing site. It is worth noting that the launch of Chang'e 4 is part of China's Lunar program, which involves a step-by-step exploration of our satellite. The mission consists of 3 stages, and the goal of the second intermediate stage is to organize soft landings of lunar rovers on Earth's satellite. But let's get back to U-22. A few hours after landing, the Chinese 140-kilogram rover Jade Rabbit 2 smoothly rolled off the landing module and accidentally went into a week-long hibernation. Meanwhile, the Chang'e 4 station went through a long trial by fire. The lunar day turned out to be a real scorcher. What equipment does the lunar rover have to perform its mission effectively? It's literally packed with useful features. It has 4 panoramic cameras, a ground-penetrating radar for probing the layers of regolith, an infrared spectrometer, and an atomic analyzer that measures the intensity of the interaction between the solar wind and the moon's surface. All the instruments were developed by the world's best engineering laboratories. For example, the radiometer was created by German specialists, and it will help measure the level of radiation exposure that future astronauts will face. The lunar rover is powered by a nuclear source that operates using the decay of plutonium-238. What hopes do scientists have for the lunar rover, U-22? First of all, it is the collection and study of soil samples. Experts hope to find fragments of rock on the moon that were ejected by meteorites from beneath the upper layers of the mantle. This will shed some light on the geological structure of our satellite. The lunar rover will also measure the temperature amplitudes of day and night and will try to find water. Among other things, the mission will allow us to test deep space communication capabilities and conduct low-frequency radio astronomy observations. On the far side of the satellite, Earth's interference doesn't threaten the equipment. This will shed light on understanding the nature of the radiation that was present in the universe during its early stages of development. To be able to hear the Chang'e 4 station, which is outside the direct line of sight, a relay satellite called Queqiao was launched, whose name literally translates as Magpie Bridge. The probe entered orbit at the Lagrange point. Why is it equally visible from both the Earth and the Moon? What has the little one done during this time? U-22. We don't want to disappoint you, but mostly the rover was sleeping. After coming out of hibernation mode on January 10th, U-22 spent 4 days busy with a photo session. And on January 14th, with the arrival of the harsh lunar night, the rover and the lander went back into protective hibernation. After all, as soon as the sunlight stops shining on the surface of our satellite, the temperature here drops to minus 190 degrees Celsius. On January 29th, the lunar rover finally continued its mission. The most important experiment, unprecedented in the history of space exploration, was the biological experiment with plants and insect eggs. A container simulating artificial biosphere conditions was installed on board the station. In addition to soil, water, and air, the pressure chamber contained potato, rapeseed, Arabidopsis, and cotton seeds, as well as eggs, fruit flies, and yeast fungi. The heat controller maintains a constant temperature of plus 25 degrees Celsius in the container. After the landing of Chang'e 4, the seeds were immediately watered, and miraculously, after 12 days, the cameras recorded the sprouting of cotton. This is a significant breakthrough, as nothing like this has ever happened on the surface of another celestial body. Due to the onset of lunar night, the support system was turned off and the experiment ended, but a start has been made. Research in this area will be expanded and supplemented, which will help gain experience for establishing future lunar bases, where similar ecosystems will have to be created. The mission brought glory to China. Before this, no spacecraft had landed on the far side of the moon, but the rover still faces a difficult task. On February 27th, the Xinhua agency reported that the spacecraft encountered its first difficulties due to the complex terrain of the lunar surface. Despite having 6 maneuverable wheels and an all-wheel drive base, U-22 is having difficulty moving, so the team is somewhat puzzled and is looking for suitable routes for the rover. Obstacles are inevitable, but the mission organizers never expected the mission to be easy. One thing is important: a detailed study of the far side of Earth's satellite. It was undertaken not to find evidence of a lunar conspiracy, but to make life easier for future colonists who will find themselves in a foreign, hostile, and extreme environment. A new era of space exploration in preparation for a manned mission to the moon has begun. This gives hope that our descendants will eventually be able to travel freely on vacation to neighboring planets. On February 13, 2019, the world said goodbye to the hard-working electronic messenger from Earth on the red planet, the Opportunity probe. Let me remind you that the last communication session with it took place on June 10, 2018. Then, as a result of a global dust storm, the probe was forced into hibernation because its solar panels, covered with Martian sand, stopped working. Scientists made repeated attempts to contact Opportunity, but it never responded. A collective decision was made to terminate the mission as not cost-effective. The device had been operating on Mars since January 2004, providing many useful discoveries and incredibly beautiful photos. Opportunity exceeded all expectations, especially in terms of its duration on the surface of our dusty neighbor. Instead of the required 90 sols, just over 92 Earth days, the probe stayed on Mars for about 5,500 days, which is about 15 years. During this time, the device traveled more than 45 kilometers. Let's trace the journey of this small but efficient machine, lost in the sands of a distant planet, until the device became part of history. Let's start with the appearance of the long-lived probe. Parameters of Opportunity. The device, launched from Cape Canaveral in 2003, weighs 185 kilograms. Due to the much lower gravity on the red planet, this weight is equivalent to 70 kilograms. The dimensions of Opportunity are modest, 1.6 by 2.3 meters, and the height of the probe is 1.5 meters. The starting point of the journey, the landing of Opportunity, did not occur exactly at the intended location, but with a correction of 25 kilometers. But this fact turned out to be fortunate, because the probe landed right in a crater that astronomers never dreamed of studying. A pit 22 meters deep, which was later named Eagle Crater. Opportunity landed on one of its slopes, just 10 meters short of the outer edge of the meteorite crater. As soon as it touched down on the surface, the probe took several panoramic shots of the crater. Before the eyes of people on Earth appeared a dry and barren world, painted in brownish shades. Already during the first Martian day, the rover surprised its creators. The probe discovered areas where bedrock had come to the surface. According to many experts, this indicates that there was once water on Mars. Overall, the Meridiani Planum, located south of the equator, was chosen as the landing site. It's no coincidence that there is a lot of crystalline hematite here, a mineral that forms only in hot springs or bodies of standing water on Earth. This once again confirms the theory of Mars' watery past, and after the research conducted by the probe, the 1,000-kilometer Meridiani Planum is officially considered the floor of an ancient ocean. The unique Martian trench. No rover had ever tried to penetrate the Martian soil before, but Opportunity managed to do it in just 22 minutes. Desperately maneuvering on one wheel while the others remained stationary, the probe dug a shallow trench, 10 centimeters deep and half a meter long. But despite the tiny size of the trench, the device discovered something inside. The micro camera couldn't differentiate the soil, since it was too fine-grained even for its resolution. but it did find shiny, perfectly shaped spheres. That was the very hematite, aptly nicknamed blueberry by scientists. Earth-like clouds on the red planet? After Eagle Crater, the starting point of a 15-year journey opportunity headed toward another meteorite crater called Endurance. The crater is only 20 meters deep. At its bottom, the rover spent half a year studying soil layers, individual rocks, and once again convincing scientists that there were once seas and oceans on Mars. But the most amazing event happened while descending into Endurance. An opportunity captured a fragment of the sky where he photographed the thinnest cirrus clouds, resembling those on Earth. The Pioneer probe wasn't wandering the Martian wastelands for 15 years for nothing. In many ways, it was the first, discovering and accomplishing things that other devices hadn't done. For example, climbing out of the Endurance crater in January 2005. An opportunity was given the command to examine the landing site. It was there that an unexpected discovery was made. A nickel-iron meteorite was found, which was named the Heat Shield Rock. A strange name, isn't it? But that's only at first glance. Once you remember where the rock was found, everything becomes obvious. Heat Shield Rock was discovered by the probe, right behind the heat shield that was jettisoned during landing. It was impossible to drill into a boulder the size of a basketball using the tools installed on the probe. In any case, the Heat Shield Rock became the first meteorite found on another planet. 40 days of confinement on Earth. We're used to solving problems quickly since people have many tools at their disposal for that. But when remotely piloting a probe on Mars, everything works against us. Communication delays, dust storms, and the dust itself, thick and sticky. It was in this dust that Opportunity got stuck on April 26, 2005. If this had happened on Earth, the process of getting free would have been very simple. Considering the weight and size of the vehicle, it would have been easily pushed out of the crater. On the red planet, this doesn't work, especially at such an unfortunate moment. There was no experienced Martian like Matt Damon next to the probe. They had to operate remotely, which kept the vehicle trapped in the sand until June 4th. Only on May 13 was a rescue strategy for freeing it developed and tested on Earth. All this time, for 40 long days, the Mars rover was completely immobilized. The stages of the great journey over the years of traveling across the barren Mars. Opportunity visited the Erebus, Victoria, Conception, Santa Maria craters, the huge Endeavour crater with a diameter of 22 kilometers Perseverance Valley, and the Marathon Hills. At Matijevich and Solander, he safely survived several dust storms and the failure of some components. He studied strange rocks, gypsum veins, and unusual locations like Duck Bay or Greeley Haven. The rover collected a huge amount of data, from a detailed report on the weather of the red planet and analysis of its soil to recording the visible transit of Phobos across the solar disk and finding indirect evidence of the presence of fresh water after studying the Esperance 6 rock. It has been proven that the boulder was washed by water with a neutral pH level billions of years ago. Before that, it was believed that the liquid flowing through Martian valleys and gullies was similar to sulfuric acid. Lethargic sleep. Near the Endeavour crater, Opportunity went into hibernation on the slope of the massive 22-kilometer Endeavour crater caused by a dust storm over 7 meters high. The storm, which raged for several months, turned the Martian day into gloomy, blood-red twilight. This was clearly recorded by Curiosity, the probe operating in another location. The storm engulfed the entire planet but did not cause significant damage to the other rovers. However, Opportunity, which was powered by solar panels, died in its sleep. Critically low temperatures during the Martian night also played a negative role. Global attention to the mission's conclusion is justified. While on the red planet, the probe revealed to us an unknown desert world like no other device before it. It studied it as much as possible, providing convincing evidence that Mars was not always dead and dry. The era of opportunity. The era of opportunity. The journey of the rover, which exceeded its expected lifespan, ended when the 9th and final attempt to contact the probe was unsuccessful. The observable universe spans about 90 billion light years, so it's reasonable to assume that the part of the universe we can't observe is much larger. Space is so vast that the human mind simply cannot comprehend it, at least for now. However, according to some theories, it might turn out that space is much smaller than it seems to us. How is that possible? Welcome to the Hubble channel. Today we will try to guide you across the bridge connecting the macro and micro worlds. According to current data, the part of the universe that is still unobservable might be about 20 trillion light years in diameter. Just imagine that. Based on the data we have, it can be assumed that most of outer space must be empty, because the amount of matter in our part of the cosmos that has been studied is quite small. When we look into space, we see gigantic, vast expanses of icy emptiness. But what if the universe could fit inside a single atom? It sounds absurd, but don't rush to be skeptical. This theory, which seems more like philosophical science fiction, might not be so unbelievable after all. But first, remember what you know about matter. All matter is made up of tiny particles, atoms. These tiny particles are the very foundation upon which the universe, as we know it, is built. Atoms are so small that even with the most powerful optical devices, we can't actually see them. An interesting fact is that we can't even know for sure what an atom actually looks like. We can only speculate based on scientific theories, since we can't see atoms with our own eyes. It is also considered a proven fact that atoms themselves are made up of even smaller subatomic particles, such as neutrons, protons, electrons, and quarks. Nowadays, it is well known that atoms are so numerous and tiny that the body of an average adult consists of approximately 7 octillion atoms. Let me remind you that this number can be written as a 7 followed by 27 zeros. Just imagine that amount. But the atom in turn also has its own structure and complex organization, and it is this that allows us to consider the incredible theory of microfibrils. What does an atom look like, so to speak, from the inside? From your school chemistry course, you probably remember that an atom consists of a nucleus, which is made up of protons and neutrons, and electrons moving around it. This model, proposed by Ernest Rutherford in 1911, was called the planetary model of the atom. Indeed, the analogy is obvious, since the movement of electrons around the nucleus is very similar to the movement of planets around the sun. Moreover, this model has never been disproved and is even supported by modern research, with the caveat that the motion of electrons should be described by the laws of quantum mechanics, not classical mechanics. That is, the smallest particle, which is the basis of matter, has a structure similar to nothing less than the solar system. Could this be just a coincidence determined by the laws of physics? Or is there something more, something much more fantastic hidden in this similarity? Let's return to this question later, but for now, try to answer this. How many electrons are there in our universe? Sounds absurd, doesn't it? Even the most powerful computer couldn't process such a number, let alone the human brain. But what if I told you that there is only one electron? This is exactly the hypothesis put forward by the American physicist Richard Feynman, called the one-electron universe theory. And it sounds like pure science fiction. According to it, there is only one electron in the world, which moves through space and time so quickly that it seems to us as if there are a great many of them. Just one particle gives shape to everything we consider the entire universe. How do you like that? Of course, this theory didn't gain many supporters, But the funny thing is that thanks to the principle of electron indistinguishability, the impossibility of experimentally distinguishing one electron from another, you can't disprove it either. That's the paradox. But let's get back to the structure of the atom and the incredible theories it gives rise to. Let's try to answer the question, what is the size of an object? Despite the everyday and familiar meaning of this word, in reality, the concept of size is quite mysterious and relative. For example, the world around us is tailored to our size because we built it. But when it comes to the creations of nature, things are far from simple. Mountains are huge for us. Planets are so gigantic that it's impossible to comprehend. But what about ants, as well as all microscopic life forms, from just small to microscopic? Do ants consider themselves small? Do they realize they live in a world of giants? It's unlikely that their world is as familiar to them as our world is to us. Compared to cosmic objects, we aren't even microscopic. We're talking about even smaller scales. That thought gives me goosebumps. And it's no wonder. The great master of horror and science fiction, H.P. Lovecraft, often promoted the idea of humanity's insignificance in the face of the endless cosmos in his works. And here we come to the main question of our video. What if our universe could fit on the tip of a needle just like that? The solar system is just an atom, one of countless others existing as part of some other kind of matter. Based on this theory, it's logical to assume that the atoms and particles that make up our own existence could also contain entire worlds within them. It turns out, as one wise man said, infinity really is not the limit. It turns out that our reality could really exist at the subatomic level of a completely different reality. And in the same way, entire worlds could be located at our own subatomic level, and so on to infinity, both towards decreasing and increasing scales. It sounds unbelievable, but exploring the unbelievable is our job. The most interesting thing is that by looking at the universe we know and observing the laws that operate within it, we can easily come to the same conclusion. Everything starts with the tiniest particles, like the atom, and ends with colossal celestial bodies and entire star clusters. Everything, from your lunch today to some recently discovered exoplanet, is made of the same building material. The dream of the scientific world is to find a theory of everything, and the question of the relationship between the micro and macro worlds is a crucial building block in working on this theory. By combining quantum mechanics and classical physics, a generation of young scientists may be able to understand the true nature of our universe and even what lies beyond it. After all, even according to one of the most popular versions of the origin of our universe, it began as an infinitely dense and yet tiny singularity. And then from this small point, it expanded to all known limits. This is called the Big Bang Theory, from something small into something much greater. Don't you think that this ties in well to what we've talked about today regarding the micro and macrocosm? Yes, but there's an important caveat. A point is not the same as an atom. The singularity that gave rise to the Big Bang, despite its small size, contained everything necessary for the creation of the entire universe. And you still can't call this an origin from a single atom. There is also what is known as string theory. It's an excellent candidate for a theory of everything. The general idea of this incredibly complex theory, which has many interpretations, is that an atom is not that spherical object whose shape and appearance we remember from school, but rather strings or something very similar to them. The relationships between these vibrating strings include almost all the laws of classical physics known to science, including gravity, as well as quantum mechanics. But string theory also has its weaknesses, even though it explains a lot. It starts to stumble, for example, when it comes to dark matter, where string theory begins to falter. But there's no need for pessimism. Scientists have been struggling for a long time to incorporate the study of dark matter into string theory. At the end of 2018, Swedish scientists published a new version of string theory, according to which our universe exists on the edge of an ever-expanding bubble. This version discards the familiar 4 dimensions, 3 spatial and 1 temporal, and suggests that our entire universe is merely fluctuations on the surface of this bubble. What happens inside the bubble or at a distance from it remains a mystery. What do you think of this perspective? We are just one small civilization, a dot in a tiny piece of reality located on the surface of the bubble, which itself in turn may be part of something much greater. Perhaps our entire world is just a proton or a quark, just a tiny particle of reality. Why don't we feel this in any way? Does the atom that makes up your sunglasses feel that it is just an atom that forms the plastic? But is it really that important to get a definite answer to this question? After all, we should just be grateful that our vast common home called the universe is full of such amazing mysteries. Exploring these mysteries is our task, and we hope you enjoyed our video. Share your thoughts in the comments, and don't forget to like and subscribe to the channel. See you next time on Hubble.